Hello from Facebook London. My name is Sameen Jalal, and I'm going to be talking about Hypershell. I'm a production engineer to start, and my background is in cache, but I recently moved to security, so I took on this tool. So what is Hypershell? Hypershell is a push-based, massively parallel command execution tool. It lets you do things like HSH exec, give it a list of targets, and runs a command on it. Probably looks very familiar to other tools, but there's a reason we have a little bit different, scale related. But we can also deploy a file to a bunch of machines given a location as well. So what could it be used for? It could be used for ad hoc queries, deployment, configuration updates, collecting stats, emergent situations, and a lot of other things as well. Hello. What should it be used for? Literally none of those things. There's probably a better tool that helps you do these things for you. Unix philosophy, keep it simple. Do one thing and do it well. So why was it built? Well, it's very easy to work with this tool. It gives you a really big hammer to really do whatever you want. It's easy. It works, and you also have persistent results, which is much better than running SSH every single time. So how does it work? Well, at the base case, you have a target and you have an agent. And the agent will SSH into the target and run a command, and that's it. You also want to save the data, so the agent, after running the command, will write to the database with the output and with any metadata that you have. But imagine you have multiple groups of hosts. So you have multiple agents and multiple targets. One agent could have multiple machines that's logging into and saving the output to, and then writing it all to a local database. But this is a pretty big, it's a mindfuck in terms of coordination. So you need one coordinator to manage all the agents, and then also pull from the database after all the output's saved to the database. So you don't actually have too much network communication between the servers and the agents, only the first time to transfer over any kind of authentication or metadata that you need. So the server in this case is going to be responsible for managing parallelism, timeouts, retries if the agents fail, and just other general things. So this is what I classify as a job. It's a pretty complicated interaction between the server and multiple groups of agents. So you can have maybe 3 different clusters that the server is managing at the same time, and each of the clusters are going to be writing to its local database. So this is a job. And how do you invoke a job? Well, it could be either a human or it could be a script that invokes the job. And it'll basically run a thrift call. To explain thrift, it's just an RPC call between a client to a server in this case, and you give it all the metadata, including what your timeouts are, how many you want running at a time, and what the command you want to run as well. So this is what the ecosystem of Hypershell kind of looks like. It is, let's say you have 2 different jobs that an origin will invoke. The first job will manage, let's say, clusters 1 through 9, and each pull 9 different databases to look for the output and the progress of each job. Job 2 could be managing only clusters 7 through 9 in this case, managing 3 different databases. And it all runs very well. So for thousands of machines, you can only have a few servers and a few agents running to save the output. Now, what are some features you can have built on top of this? I'm not promising all these things are built, but they're all in the pipeline at least. So you can have something like staged jobs with confirmations in between. So let's say you run your job in 100% of a job 10% at a time. And after every 10%, you ask for confirmation feedback from either a script or a human saying, can I continue to the next batch? And that way you can make sure you don't destroy the entire 100% of the fleet when you run a command. That's potentially dangerous. You could have explicit read-only commands. This is to make sure you don't have too many permissions. You can make your job very visible. So if a job's running on my servers, I would like to know that someone's running this job on my servers. Some sort of security logging. And approval from service owners. So let's say I'm on the cache team and I want to access Hadoop, then I probably don't need access on a daily basis. I probably only need access just for that job's invocation. So I'd ask the service owners if I can go through, and there's an escalation process as well that you can go through for Hypershell. And tiered authentication. Oh, damn. By tiered authentication, I mean something like you human, say I want to invoke this job. These targets are going to run this command. And on the last step of the hop, so the clients, servers, agents, and then target, the agents will also authenticate saying, I was the agent that was given access to this machine. So you don't have any way of tampering with the actual message across, and you don't tamper with the command. And great power comes great responsibility, as from the great Uncle Ben of Spider-Man, and as Facebook engineers say, Hypershell. These are some resources. This is what this is the read up on Thrift and services running on Thrift, and I think that's it. It is not open source yet. If you have any questions, I'll be at the booth. You can also find me on Twitter.